Hello students, in this video I'm going to discuss the MCQ type problems based on the topic function of several real variables. So in this particular video I'm going to discuss the MCQ type problems based on the topic function of several real variables. So let us start with the first problem. So the first problem is based on the limit of the function limit xy approaches to 0 x upon square root of x square plus y square. So in this case, if I put x equal to 0 and y equal to 0, then we find that it is 0, 0.0 form. So it is 0, 0.0. So when it is 0, 0.0 form, firstly we need to check that either in this case limit of the function exists or not. So how can we check the same? Here the degree of numerator is 1. The degree of denominator is also 1 because square root of x square plus y square means degree of denominator is also 1. And I told you that when the degree of numerator and denominator is same in the 0, 0.0 form case, then the limit of the function does not exist. And when we have a factor x square plus y square there, then preferably we convert it into polar form, right? So to prove the same, so the first step is we simply convert it into polar form. Let x equal to r cos theta, y equal to r sin theta. So x square plus y square is equal to r square. So as xy approaches to 0, 0, it implies that r approaches to 0. So this limit problem now converted into limit xy approaches to 0, 0. X square x upon square root of x square plus y square. This is equal to limit r tends to 0. This is r cos theta. And square root of x square plus y square is nothing but r because here r represents the radius. And radius of a circle is always positive. So square root of r square is r only, right? So in this case, your limit is cos theta. But what is theta? Here theta is arbitrary because theta can assume any value. For different values of theta, we have a different limit, hence limit does not exist. So we can easily prove in this case that the limit of the function does not exist. Let us come to the next question. Here, we want to find out the value of alpha such that your function is continuous at the point 2, 2. So the definition of continuity states that limiting value of the function at a point is equal to the value of the function at that point. If this condition is satisfied, it means your function is continuous. So what is f of 2, 2 here? Here at the point 2, 2, the value of the function is alpha. So it means that its value is alpha. It is equal to alpha. So to get the value of alpha, we simply need to find out the limit of this function. So to calculate the limit of the function means whenever we choose the value of the function in the neighborhood of a point, it means we are considering this particular region and x is not equal to 2, x and y is not equal to 2. So your function is x square plus xy plus x plus y upon x plus y. Now because your function, if I put x equal to 2 and y equal to 2, your function is defined. So we can directly get the value by replacing x equal to 2 and y equal to 2. So this is 4 plus 4 plus 4 is 12. 12 upon 4, so its value comes out to be 3. So the limiting value is equal to 3 and its value is equal to alpha. So it means that alpha is equal to 3 only. So this is the answer in this case. Let us come to the next question. Okay, the next question is using delta epsilon approach, then what is the value of delta such that this? So in delta epsilon approach, we are saying that for any given epsilon greater than 0, so that f of xy minus L is less than epsilon. So what is f of xy? This is our function f of xy, and this is our L. So means we are already choosing f of xy in this way, and L is 2. So we need to find out the value of delta. That is, what kind of delta we need to choose such that this difference is less than epsilon. So we are saying let delta greater than 0 be any real number such that these 2 points are very close, means x minus 1 whole square plus y minus 1 whole square. This should be less than delta. Or this will also gives us two more condition, that x minus 1 also less than delta and y minus 1 also less than delta. Okay, because if this factor is 0, it means mod of y minus 1 less than delta. If y minus 1 is 0, it means x minus 1 is less than delta. So with the help of these three conditions, I want to establish a relation between delta and epsilon. So for that, we consider mod of x plus y minus 2. So because the condition is given in term of x minus 1 and y minus 1, so we convert x as x minus 1 plus 1, and similarly y as y minus 1 plus 1 minus 2. So this is x minus 1 plus 1, y minus 1 plus 1 minus 2. So this 2 get cancelled out, and we have a property that mod of a plus b is less than equal to mod of a plus mod of b. So if we use this condition, this is less than or equal to mod of x minus 1 plus mod of y minus 1. But mod of x minus 1 is less than delta, and mod of y minus 1 is also less than delta. So if we use this condition, this is less than delta plus delta, that is 2 delta. But this term is less than epsilon, so it means that it should be less than epsilon. So it will gives us the relation that 2 delta is less than epsilon, means the value of delta is less than epsilon by 2. So what kind of delta we need to choose so that this term is less than epsilon? The relation is delta should be less than epsilon by 2. Okay, so here we are going to use delta epsilon approach. Okay, now let us consider another problem of limit. So here this time we are given xy approaches to 0, 0, x plus y upon x square plus y square plus 1. And this time, if I put x and y equal to 0, 0, your denominator is 1, which is not equal to 0. So it means your function is defined. So I simply replace x equal to 0 and y equal to 0. So the limit comes out to be 0 only. Okay, so if your function is defined, then the limiting value is equal to the value of the function. So we just simply put x equal to 0 and y equal to 0, and we get its limit as 0 only. Okay, the next part is your function is defined in this way that when xy is not equal to 1 minus 1, it is 1 upon x plus y, and when xy is equal to 1 minus 1, it is 0. Means f of 1 minus 1 is given as 0. Means your function is defined. Now the next one is about the limit and the continuity. For continuity, the condition is the limit should exist. This is the necessary condition for the continuity. This limit should exist. Okay, so if limit does not exist, there is no question about continuity. So let us firstly check the limit of this function. So your function is 1 upon x plus y, and if I put x equal to 1 minus 1, your numerator is non-zero, but your denominator tends to 0. It means that this limit does not exist because it maybe tends to 0 from positive or negative. Accordingly, limit tends to plus infinity or minus infinity. So limit does not exist. 1 upon 0 means limit does not exist. So limit does not exist, so it means your function is not continuous. So it means only second statement is correct. So it means correct answer is option B. Okay, now this is another type of the problem. Here again, if I put x equal to 1 and y equal to 0, your denominator is 0 and numerator is also 0. So it is 0.0 form. But if you just look at this function can be split as a product of two functions. 1 minus x log x, this is a function of x alone, and sine y upon y, this is a function of y alone. And if it can be expressed as a product of two functions, so we can split the limit as a product of two limit. 1 minus x upon log x, because it depends upon x only. So we apply the limit of x, and here this depend upon y only. So we apply here the limit of y. And we use the property here that this limit is equal to 1. To calculate this limit, we can apply here L'Hopital rule for one variable function because it is 0.0 form, indeterminate form. So what can we do? We differentiate numerator function. Derivative 1 minus x is minus 1 and derivative of log x is 1 upon x. Okay, because according to the L'Hopital rule, if limit x tends to x naught f of x upon g of x, this is equal to limit x tends to x naught f dash x upon g dash x if f dash f of x naught and g of x naught, both of them are 0, but g dash x naught should not be equal to 0. So now if I put 1, then its limit comes out to be minus 1. So this limit is minus 1, this limit is 1, so product is minus 1. So hence the correct answer is option A. Okay. So in this case, although it is 0.0 form, but it is a special type of a limit when we can express our function as a product of the two function. So we calculate the limit of the each of the parts separately, and rest we take the product to get the required result. Okay, now the next one is based on the definition of continuity. The definition of the continuity is limit xy approaches to ab f of xy is equal to f of ab. So what is the definition? State that if the limiting value of the function is equal to the value of the function, then your function is continuous. Means for any given epsilon greater than 0, however small, there exists a real number delta greater than 0 such that the difference of these two numbers is very small, less than epsilon, whenever the we choose a point in the neighborhood of a point AB. Right? We know that the neighborhood of a point is a circle. So if this is a point AB in a plane, then the neighborhood of a point is a circle. So we are choosing the delta neighborhood of a point. So if we choose any point in the neighborhood of this point, then the value of the function approaches to this point. Means the difference between these two numbers is very small whenever we choose a number very close to this number. So the correct answer is, the correct answer is option D only. That the difference between these two is very small whenever we choose a number very close to the point AB. So basically here it should be Y. Here in the option both sides it is written X only, but it should be Y. Okay. Let us come to next question. Next question is based on Jacobian of xy with respect to uv. So by definition, this is curly x upon curly u, curly x upon curly v, curly y upon curly u, curly y upon curly v. Derivative of first with respect to 2, derivative of second with respect to 2. Okay. So derivative of x with respect to u. When we differentiate with respect to u, v is constant. So this whole term is constant. And derivative, when we differentiate with respect to v, then u is constant. Derivative 1 is 0. Derivative with respect to v is 1. Similarly, when I differentiate with respect to u, v is constant. Derivative with respect to v means u is constant. So this is basically 1 plus v. Here it is u, here it is v, and 1 plus u. So if we expand the determinant 1 plus v into 1 plus u minus uv, so this is 1 plus u plus v plus uv minus uv. Answer is 1 plus u plus v. The correct answer is option C only. Okay, so the next question is based on the partial derivative. So we are given u is a function of x and y, and we need to find out partial derivative with respect to x and y both. And we know that if we differentiate with respect to x, then we are treating y as a constant. And when we differentiate with respect to y, then we are treating x as a constant. So when we treated y as a constant, it is like derivative of a power x. And its derivative is a power x log of. So y is constant, so y power x log of y. And when we differentiate with respect to y, x is treated as constant, it is like derivative of x power n, power root. So x is constant, so x y power x minus 1. So the answer is y power x log y and x times y power x minus 1. Next question. We need to find out derivative with respect to xy means curly square f upon curly x curly y. So we are given f as log of x into tan inverse y. When it is not mentioned and there is a problem based on the derivative, so we are assuming log as a natural log, right? So it is basically log of x plus log of tan inverse y, using the property that log of AB is equal to log of A plus log of B. Okay, so this is the property of log. So if I want to calculate curly, because this is same as curly square f upon curly y curly x. So we can calculate in any ways. For example, if I differentiate firstly with respect to x, derivative log x is 1 upon x. Because y is taken as constant, so it is 0. And now if I differentiate with respect to y, and its derivative is 0. Otherwise, if I firstly differentiate with respect to y, then x is treated as constant, its derivative is 0. So it is a composition of the function. It is like the case that is a function of single variable, and this single variable depend upon two variables. So if I want to find out its derivative with respect to x, so first I differentiate first function and then differentiate u with respect to x. Okay. So its derivative is derivative log 1 upon tan inverse y, because the derivative of log x is 1 upon x, and derivative of tan inverse x is 1 upon 1 plus x square into derivative tan inverse y is 1 upon 1 plus y square. But now if I differentiate with respect to x, because it is a function of y alone, so automatically its derivative will be 0. Okay. So because it is a sum of two functions, one depend upon x only, other depend upon y only. So automatically the second order derivative with respect to other variable is always 0. Let us come to next question. So we need partial derivative of function with respect to t. So here we find that f is a function of x and y, but these two are function of t. So you can apply here the definition of derivative with respect to t means with respect to x, with respect to t, with respect to y, with respect to t. So what is df upon dt? It is curly f upon curly x dx upon dt, curly f upon curly y dy upon dt. But we need its value at t equal to pi by 2. Means we need to calculate their value at t equal to pi by 2. So firstly, we calculate the value of x and y at t equal to pi by 2. What is cos pi by 2? This is 0. What is y at t equal to pi by 2? It is sin pi by 2. Its value is 1. And what about dx upon dt? Derivative cos is minus sin t. So derivative dx upon dt at t equal to pi by 2. This is minus sin pi by 2. Its value is minus 1. And dy upon dt at t equal to pi by 2. Firstly, I need to calculate dy upon dt. Derivative of y with respect to t is cos. Derivative sin t is cos t. So its value at t equal to pi by 2. Cos pi by 2 is 0. Okay, so what is the derivative of f with respect to x? So firstly I calculate df upon dt. So its derivative is cos x plus y square, and dx upon dt, this is minus sin t, and its derivative with respect to y is minus sin y plus 2y x, and derivative of y with respect to t is cos t. So if we calculate its value at t equal to pi by 2, it means cos x plus y square at t equal to pi by 2 and minus sin pi by 2, and here it is minus sin y plus 2xy at t equal to pi by 2 into cos pi by 2, right? And now this term is 0, cos pi by 2 is 0. So this term is 0, it means this whole term is 0. And cos pi by 2 is also 0. X is x at t equal to pi by 2 is 0. So it means this is 0, cos 0, and y at t equal to 0, its value is 1. So answer is 1 plus 1 is 2 into minus 1 into minus 1. So its value comes out to be minus 2, right? Because x is 0 at t equal to pi by 2. So cos 0 is 1. This is 1. And y is already 1. This is also 1. And sin pi by 2 is also 1. So minus 1 into 1 is minus 1. And 1 plus 1 is 2. So 2 into minus 1 is minus 2. So this is the value of the function. Okay. So the important thing is whenever the derivative is expecting at a specific value of the independent variable, that means we are expecting answer in a constant term. Means after calculating the partial derivative of the function, we need to calculate its value also at the value of this variable. Okay, let us consider next question. If z equal to, this is again a composition of the function and we are expecting the value of this part. Okay, so here we have one important result, that this is a result of Euler's theorem, which state that if z is homogeneous in x and y, if z is homogeneous in x and y and is of degree n, right, then x time curly z upon curly x plus y time curly z upon curly y, this is equal to nz. So this is the result we have. But in this case, your function is not directly homogeneous because of the presence of exponential function. Okay. Otherwise, how do we check that a function is homogeneous? If we replace x with lambda x and y with lambda y, then this lambda should be taken completely outside and we should left with a function xy. But here you can see the degree of numerator is 2, the degree of denominator is 1. So it means that if I replace, we left with lambda in the numerator, and because of the presence of exponential, it is not possible to separate this lambda from the function. Okay, so it means your function is not directly homogeneous, but if we take log, here, that is log of z, this is x square plus y square upon x plus y. Now this function is homogeneous. That means if I replace here x with lambda x, y with lambda y, and this is lambda x square lambda y square upon lambda x plus lambda y, and lambda square is common from the numerator and lambda is common from the denominator. So one power get cancelled out, so we left with lambda time x square plus y square upon x plus y. That is lambda time log of z. Okay, so it means that logarithmic z is a homogeneous function. So this is a homogeneous in x and y and is of degree 1 and is of degree 1. Then according to Euler's theorem, so this result is applicable for log of z. X curly x of log z, y curly y of log z. This is equal to n time log z. What is n? It is 1. So now the derivative of log z is 1 upon z. So if we multiply z on the other side, so we can get x curly z upon curly x, y curly z upon curly y. This is z time log of z. So it means that the correct answer is option C. Okay. So you can see here with the help of the property of Euler's theorem, we can easily get the answer. But otherwise, if we differentiate this, then we need to apply the chain rule for the derivative composition of the function and then again quotient rule. So it is not the easy task. It is very tedious job. Okay. So in that case, it is easy. If we apply Euler's theorem, you can easily get the answer in this case. Okay. Again, this is a similar kind of problem. Again, we are expecting the value of x curly u upon curly x plus y curly u upon curly y. But what is your function here? U is f of rs. What is r? X upon y. And what is s? Y upon x. So it means your variable is x upon y. X upon y means it is of degree 0. Means if I replace here x with the lambda x and y with the lambda y, then this is f of lambda x upon lambda y, lambda y upon lambda x. They will cancel out. This is similar as f of x upon y, y upon x. So this is lambda raised to power 0 time u of xy. It means that it is a homogeneous function with degree 0. Homogeneous function degree 0. According to Euler's theorem, the value x curly u upon curly x plus y curly u upon curly y, this is equal to nu. What is n? 0. So answer is 0. Right? Okay. Now let us move to the next question. In this case, we are given over one function and we are expecting value of curly z upon curly x. Curly z upon curly x means z is a dependent variable. This is your dependent and this is your independent variable. So dependent means that we need to express z as a function of x and y. But if you just look at this expression, in this case, it is not possible to express z as a function of x and y because your function here f of x, y, z is x square y plus xz plus z square equal to 4. It is not possible to find out the value of z in terms of x and y. So this is an implicit function. This is an implicit function. And in case of implicit function, the value of curly z upon curly x, this can be obtained by taking the ratio of minus of f of x upon f of z. Z is in the numerator, then f of z in the denominator. X is in the denominator means f of x in the numerator, right? So f of x means partial derivative with respect to x. So its derivative with respect to x is 2xy plus z, right? Because this is your function. And its derivative with respect to z is 0 plus x plus 2z. If I substitute here, this is minus of 2xy plus z, and here it is x plus 2z. So the correct answer is option C. Okay, now come to the next question. This question is that we need to find out the critical point. Critical point means this is a problem based on relative maximum and minima. So for critical point, we need to find out its partial derivative with respect to all the variable. So this is 4x plus 2y minus 6, and partial derivative with respect to y is 0 plus 2x plus 4y minus 0. So the condition for the critical point is first order derivatives are 0. Curly f upon curly x equal to 0 and curly f upon curly y equal to 0. So this will gives us 4x plus 2y minus 6, and here 2x plus 4y equal to 0. So 2x plus 4y equal to 0 means x equal to minus 2y. And if we replace it here, 4 times minus 2y plus 2y minus 6. So minus 8y plus 2y equal to 6. So minus 6y equal to 6. So the value of y is minus 1. And if y equal to minus 1, then the value of x is 2. So what is the critical point? Critical point is xy. X is 2, y is minus 1. So the correct answer is option D. Okay, so the critical point means point where the partial derivatives are equal to 0. The next question is number of critical point means the number of such kind of pair for which first order derivative is 0. Let us firstly calculate first order derivative. 0 plus 3x square plus 0 minus 3y, that is 3x square minus 3y, and derivative with respect to y is 0 plus 0 plus 3y square minus 3x, that is 3y square minus 3x. So for critical point, we will substitute curly f upon curly x equal to 0 and curly f upon curly y equal to 0 means 3 times x square minus y equal to 0, and here it is 3 times y square minus x equal to 0 means x square equal to y, and here y square equal to x. So we can substitute, let the value of x here. So it is y square whole square equal to y. So means y raised to power 4 minus y equal to 0. Y cube minus 1 equal to 0. So it means either y is 0 or y equal to 1. Because a cube minus b cube equal to 0 have only one real root, a equal to b. And if y equal to 0, what is x? X is y square. So if y equal to 0, its value is 0. And if y equal to 1, then its value is 1. So it means that the points are 0, 0 and 1, 1. So if y equal to 0 and if y is equal to 1. So the square of 0 is 0, the square of 1 is 1. So it means that the points are 0, 0 and 1. So how many points are there? 2 points. So the number of critical points are 2. Okay, the next question is, what is the nature of this point? Like in this case, the critical point is already given to us. So we want to know that either this point is the point of maxima, minima or saddle point. So means we need to check the condition here. So the first step is curly f upon curly x. This is 4x minus 4y, and curly f upon curly y. This is 0 minus 4x plus 4y cube. Okay, so for critical point, the condition is curly f upon curly x is 0, means 4 times x minus y equal to 0 means x equal to y, and curly f upon curly y equal to 0 means 4 common y cube minus x equal to 0 means x equal to y cube. So if we solve them, we get y equal to y cube. So it means that y into y square minus 1 equal to 0, y equal to 0 for y equal to plus minus 1. So if x equal to y, so the points are, if y equal to 0, x equal to 0, if y equal to 1, x equal to 1, if y equal to minus 1, x equal to minus 1. But out of this, we need only 1 point, 1, 1. Means 1, 1 is the extreme point. Now the next step is we need to check the condition. For that, we calculate second order derivative with respect to x. This is 4. Second order derivative with respect to y. This is 12y square, and second order derivative with respect to xy is curly by curly x of curly f upon curly y. This is minus 4x plus 4y cube. This is minus 4. So we need to calculate the value of r, which is curly square f upon curly x square at the point 1, 1. Already it is constant t, that is at the point 1, 1. This is limit xy approaches to 1, 1. 12y square, because function is defined, so its value is 12. And s curly square f upon curly x curly y at the point 1, 1. So already it is constant, it is minus 4. So already r and t, they are positive. What about rt minus s square? So 4 into 12 minus minus 4 square. So 48 minus 16, that is 32, is also positive. So the condition of maxima and minima is if rt minus s square is positive, and if r and t are positive, then this is the condition of relative minima. And if r and t, they are negative, then this is a condition of maxima. And if r and t are of opposite sign, then it is a saddle, right? So here in this case, the condition is that r and t are positive, and this is also positive. So it is the condition of relative minimum. Okay, now let us move to the next question. Okay, next question is based on that z is a function of u and v, and u and v, they are function of x and y. So we need curly z upon curly y. So here we need to apply chain rule with respect to u, with respect to y, with respect to v, with respect to y. So curly z upon curly u upon curly y, curly z upon curly v upon curly y. So because z is the unknown function, so this remain as it is, but derivative of u with respect to y is x square, because when we differentiate with respect to y, then x is constant. And here derivative v with respect to y is 2. So answer is x square time curly z upon curly y and 2 times curly z upon curly v. Sorry, u. Here it is u, not y. X square time curly z upon curly u, 2 times curly z upon curly v. So this is the correct answer. Okay. Again, next question is based on the limit of the function. So limit xy approaches to 0, 0. Function is y cube x upon x square plus y raised to plus 6. 0, 0 means it is 0 upon 0 form. But in this case, the degree of numerator is 4 and degree of denominator is 6. Although it is not a homogeneous function, denominator 1. So in this case, if the degree of numerator is less than degree of denominator means we need the limit of the function does not exist. But to prove this, we need to make it homogeneous. So the difference is x square. If I take its power 3, then it becomes 6. So we accordingly will choose. Let us choose a path. Let us choose a path x equal to my cube so that your denominator become homogeneous. As y approaches to 0, x approaches to 0. So we have limit xy approaches to 0, 0, y cube x upon x square plus y raised to power 6. Now this is equal to limit y tends to 0, y cube m times y cube upon my cube whole square plus y raised to power 6. So this is limit y tends to 0, m times y raised to power 6, m square y raised to power 6 plus y raised to power 6. So limit y tends to 0, y raised to power 6 is common, m square plus 1. So y raised to power 6 get cancelled out, so limit is m upon m square plus 1. So clearly limit depend upon m, but here m is arbitrary, means for different values of m we have a different limit, hence limit does not exist. Okay, so in this case what kind of path we need to choose, that is the important step. So in this case we try to make your denominator function homogeneous, automatically you can conclude here. Okay, I already told you when we choose a path and we find that limit of the function exists, it doesn't mean that the limit of the function exists, because if the limit of the function exists, it should exist along all the path. So whenever we are choosing a path, so we are trying to prove that the limit of the function does not exist. Okay, now let us come to the next question. Which of the following function is homogeneous? So homogeneous, I already told you, if it is possible to express f of lambda x lambda y equal to lambda raised to power n times f of xy, means lambda can be taken outside throughout. Here power of x is 3. Basically your function is x cube minus xy square upon x minus 1. Here 3, 3. But here, because of the presence of 1, it is not homogeneous. Here power of x is 3 and in the denominator power is 2. So because of tan, this function is not homogeneous because it is not possible to take lambda outside. Here power is 2. Here also power is 2. So the net power is 0. So it means this function is homogeneous. Here power is not same, this function is not homogeneous. So if we want to check, we can check the condition here, that log of lambda square x square minus lambda square y square upon lambda square x square plus lambda square y square. So you can take lambda square common from numerator and denominator. So it is equal to the function itself. So it is equal to the function means we can write lambda raised to power 0 times the function. It means it is a homogeneous function with degree 0. Sometimes the question is also asked about the degree of the function. So you can check the degree with the help of this criteria also, right? Okay, the next question is based on total derivative. So the definition of total derivative is if z depend upon two variables, it is curly z upon curly x dx plus curly z upon curly y dy. So what is z? It is tan inverse x upon y. So composition of the function. So curly z upon curly x means firstly derivative of tan inverse 1 upon 1 plus x square into curly y curly x of x upon y. So if we take the LCM, y square plus x square upon y square into 1 upon y. So 1 power get cancelled out, so its value is y upon y square plus x. And similarly, if I differentiate with respect to y, derivative of tan inverse is again 1 plus x upon y whole square into curly y of x upon y. So this is y square upon y square plus x square on taking LCM, and here it is minus x upon y square. So y square get cancelled out. This is minus x upon x square plus y square. So if we substitute here, so this is y upon x square plus y square dx minus x upon x square plus y square dy. So basically this is y dx minus x dy upon x square plus y square. So the important thing is the formula of total derivative. If it depend upon two variables, we have a two term. If it depend upon three variable, differentiate with respect to first variable, total change in that variable. Differentiate with respect to second variable, total change in second variable. Differentiate with respect to third variable into total change in that variable, and continue in this way. You can get the formula of total derivative. Okay. Let us come to the next question. Again, this question is based on the chain rule that w is a function of x and y, and x and y they are function of t. So we can calculate dw dt by chain rule. Curly w by curly x dx upon dt. Curly w by curly y dy upon dt. So curly w by curly x, this is 2x. Curly w by curly y is 2y. Dx upon dt. So this is d by dt of, here if I separate this term, this is t minus 1 upon t. Derivative of t is 1. This is 1 upon t. And derivative of y with respect to t. So here we need to apply the quotient rule. Derivative of u upon v, which is v square v derivative of u minus u derivative of v. So this is v square v time derivative of u. Derivative of t is 1, and u as it is derivative of v, derivative of t square plus 1 is 2t. So this is t square plus 1 minus 2t square, or this is 1 minus t square upon 1 plus t square whole square. So if I substitute all this value here in this formula, so we can get dw by dt as 2x time 1 plus 1 upon t square, 2y time 1 minus t square upon 1 plus t square whole square. Okay, but we need its value at t equal to 1. So if I put t equal to 1 means we need to find out the value of x at t equal to 1. And if I put t equal to 1 here, 1 plus 1. And here y at t equal to 1. And if I put t equal to 1, this is 0. So this is 0 means this whole term is 0. And what about x when t equal to 1? If I put t equal to 1 here, then 1 minus 1, this is also 0. So this is also 0. 0 into 2 plus 0, answer is 0 only. Okay. Okay, the next question is the critical point and its nature. We need to firstly find out the critical point. 2x minus 2, rest all terms are 0. With respect to y, this is 4y plus 4. So for critical point, we need to put curly f upon curly x equal to 0 means 2x minus 2 equal to 0 means x equal to 1. Curly f upon curly y equal to 0 means 4y plus 4 equal to 0 means y equal to minus 1. So what is the critical point? X comma y, that is 1 comma minus 1. Now for the condition of maximum and minima, we need to find out second order derivative. This is second order derivative is 2, and the second order derivative with respect to y, this is 4. And if we calculate second order derivative with respect to xy, this is 0 because this depend upon y only. If we differentiate with respect to x is 0. So what is r? This is curly square f upon curly x square at the critical point 1 and minus 1. This is 2, which is positive. T with respect to y at the point 1 minus 1. This is 4, again positive. And what about s at the point 1 minus 1? It is already 0. What is rt minus s square? 2 into 4 minus 0, 8. So rt minus s square is positive, and r and t, they are also positive. So this is the condition of minimum. So because already point is 1 minus 1, so these two condition already ruled out. And because it is a point of minima, so the correct answer is option D. Okay. So in this case, we want to find out the value of this expression. So again here, it is a case of Euler's theorem. So according to the Euler's theorem, if your function is homogeneous, in the variable x and y and is of degree n, then it has a two result. One, that x curly u upon curly x plus y curly u upon curly y, this is equal to n times u. And the second one is x square curly square u by curly x square plus 2xy curly square u upon curly x curly y plus y square times curly square u upon curly y square. This is equal to n times n minus 1 into u. So if you just look at here the degree of numerator is 3, degree of denominator is 2. So the net degree is 3 minus 2, 1. Or we can check the degree by replacing x with lambda x and lambda y. So lambda y cube, lambda x cube, lambda y square, lambda x square. So lambda cube is common from the numerator, y cube minus x cube, lambda square common, y square plus x square. So 2 power get cancel out. So this is lambda times y cube minus x cube on y square plus x square. Lambda 1 times u of xy. So the degree is 1. So degree is 1 means 1 into 1 minus 1 times u. Answer is 0. So it means that in this case the correct answer is option D only. Because here u is a homogeneous function and is of degree 1. So this term is 0 only. Okay, come to next question. For the function xyz, if m1, m2, m3 denote the leading minors, then which of the following must be true to be relative maxima? So for maxima in case of three variables, the condition is of course first order derivative should be equal to 0 at that point, right? And then we construct a matrix A, fxx, fxy, fxz, fyx, fyy, fyz, fzx, fzy, fzz. A11, A12, A13, A21, A22, A23, A31, A32, A33. Right? We are assuming X as our first variable, Y as our second variable, and Z as our third variable. So firstly, we construct this matrix. Then the first condition is all the second order derivatives should be negative. For maxima, the condition is second order derivative, all of them should be negative. And the second condition is principal minor. Principal minor m1 is f of xx, which is already negative. M2, that is f of xx, f of xy, f of yx, f of yy. It should be positive. And M3, that is the determinant of A, should be negative. They are of alternate sign. This is the condition of maxima. And what about the minima? For minima, all the derivatives should be positive and principal minors are also positive. Then this is the condition of minima. And for neither maxima nor minima if they are of opposite sign. Right? So here we need the condition of maxima. Maxima means second order derivative less than 0 and negative, positive, negative. So the correct answer is option B only. Come to next question. Here we are given u and v as a function of x and y, but we need Jacobian of xy with respect to uv. Okay, so now here we can use one of the property of Jacobian of transformation as that j into j dash is 1. Like if j is Jacobian of xy with respect to uv and j dash is Jacobian of uv with respect to xy, then their product is equal to 1. So here we need Jacobian of xy with respect to uv, but we are given uv with respect to xy. So what can we do instead of this? We are going to calculate Jacobian of uv with respect to xy. That is derivative of u with respect to x, u with respect to y, v with respect to x, and v with respect to y. So derivative u with respect to x is 1, u with respect to y minus 1, v with respect to x 1, v with respect to y 1. So 1 plus 1 is 2. So the value of, according to this, so what is the value of j? It is 1 upon j dash. This is j dash and this is j. So it is 1 by 2. So according to the property of Jacobian of transformation, we get this result. Okay, like we have discussed two property of Jacobian. One is j into j dash is equal to 1. Second is if Jacobian of transformation is 0, it means that variables are functionally related. Okay, sometime the question is that we need to check that either the variables are functionally related or not. So what can we do? We calculate Jacobian of transformation. If it is equal to 0, means the variables are functionally related. Okay, now we consider one more problem. Here the question is that z is a function of x and y, and if the partial derivative with respect to y does not exist, then which of the following is always true? So basically here the options, if you're just looking at the option, it is about the differentiability, right? So in the differentiability of the function, we have discussed that the necessary condition and the sufficient condition. The necessary condition for the differentiability is partial derivatives should exist at the point x naught y naught. Okay, that is curly f upon curly x and curly f upon curly y should exist at the point x naught y naught. This is the necessary condition. So if the partial derivative does not exist, means your function is not differentiable. Okay, because we have discussed that sometimes your function is differentiable but not continuous. So it means there is no question about continuity. But if the partial derivative does not exist, your function is definitely not differentiable, right? Okay, so we'll try to cover the different part of this particular unit problems in this video. Still, if you find out any problems on any question, if you have any specific doubt on any question, then you can send your query in the comment box. I'll try to provide you the solution of the same, right? So you will practice the topic. Otherwise, I have already uploaded the topic of the uh, different topic of this particular unit separately so that you can understand the concept, because if the concept is clear to you, then you can solve any kind of a problem. Okay, so all the best and have a nice day.